Hey there! Welcome to our lesson on measures of central tendency, otherwise known as averages. I think you're going to feel like you're familiar with all of this lesson and then be very confident with some or most of the lesson, if not all of it. But just hear me out. Make sure that you are careful and listen to this whole spiel I have to give you. But we are going to be talking about averages. We're going to be talking about mean, median, mode, and mid-range. An average is a number that represents a group of data, and it turns out that the mean, median, mode, and mid-range tend to be numbers that are towards the center of your group of data. Hence the name measures of central tendency. Um, it's important to know which average is being referenced because each one's found a different way, and they can give you different information about your data. So you want to know what average is being referenced if somebody said they found the average of something. And you also want to know which, if you're trying to find the average, which one's the most appropriate to choose. All right, so let's go ahead and take mean first. The mean is the one we tend to think of when we hear the word average. It is the most commonly found average. It's found by adding up your data and dividing by how many pieces of data you have. Usually in school, you hear about your grade point average, and that comes from the mean or from some variation of the mean. Sometimes there's drop grades, sometimes there's certain weights, but still typically the mean is the average involved in finding the grade. And there's all kinds of other averages that use the mean. It's one of the most popular, most common ones. But let's go ahead and take a couple sets of data and find the means to them. All right, let's start with the set of data containing 4, 6, 7, 7, 7, 9, 9. Okay, so you add up the 4, 6, 7, 7, 7, 9, and 9. And since there's 1, 2, 3, 4, 5, 6, 7 numbers there, you're going to divide by 7. So say we got 10, 17, 24, 31, 40, 49 over 7, which gives us 7. Okay, so that's the mean for that set of data. All right, how about for 1, 3, 5, 7, 9, 11, 13, 15. Oh, interesting, they gave us odd numbers 1 through 15. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. Oh my gosh, I gotta erase that. I can't read the numbers. And we're dividing by 1, 2, 3, 4, 5, 6, 7, 8 this time. Let's see here. Oh, I missed the one on the 15 right there. Sorry about that. So you gotta add them up. You got 64 over 8, and you get 8. And then down below, do one more. 5, 15. This is a funny set of data. 5, 15, 5, 15. So we got to add up 5 plus 15 plus 5 plus 15 plus 5 plus 15. And divide by 6. It looks like we have 60 divided by 6, which is 10. So notice sometimes your average can be one of the numbers in your set of data. Like right here, the mean was 7, and 7 was one of the numbers in the set of data. Right here it was 8. 8 wasn't one of the numbers in the set of data, but it's between 7 and 9 right here. Down here, 10's not in the set of data. If you think about 5 and 15, there's 3 5s and 3 15s. And try to average that out, you get 10 towards the center. The mean has another special property in that if you look at all these numbers on a number line, like, okay, starting with 0, we got 1, 2, 3, 4, so we have a number at 4. 5, 6, we have a number at 6. 7, we have 3 numbers at 7. 8, 9. We got two numbers at 9. And if we look at these numbers on the number line, like there were little weights sitting on this number line, then the mean, in this case 7, would be the place that you'd want to put your fulcrum to balance it, like a seesaw. If you put your little fulcrum at 7, and each of these numbers had a weight at that position on the number line, then you would be able to balance it like a little scale. So like if you looked at the numbers 1 through 15 on a number line, and you had a weight at 1, 3, 5, 7, 9, 11, 13, and 15, you need to put your little fulcrum at 8 to balance it out. And if you had a number line and you put 3 weights at 5 and 3 weights at 15, you would need your little balance on 10 to balance that out. So that's another way of thinking about the mean. All right, next one, median. The median is the middle piece of data when all the data points are arranged in either ascending or descending order. And that right there is the key that people forget. You have to put your data either from smallest to largest or largest to smallest. Then look for which piece of data is in the middle of all the numbers. If you end up with 2 in the middle, because you have an even number of pieces of data, then you find the median by adding those two together and dividing by 2. So you find the average of those two numbers in the middle. All right, so we're going to use the same sets of data we had earlier when we're finding mean. So we have 4, 6, 7, 7, 7, 9, 9. This is already from smallest to largest, and we have 1, 2, 3, 4, 5, 6, 7 numbers. So right smack dab in the middle, right here, is 7. You got 3 numbers before it, 3 numbers after it. That's what's in the middle. So that's your median. Median's in the middle. Kind of like when you're driving, the median in the road, it's in the middle between opposite lanes. All right, your next set of data was also in ascending order already, so we don't need to do anything there. It went 1 through 15 odd numbers. And there was 1, 2, 3, 4, 5, 6, 7, 8 this time. So data piece number 4 and data piece number 5 both fall in the middle. On the other side of 7 and 9 you got 3 numbers, and on the right side of 7 and 9 you got 3 numbers. So what you have to do to find the median is add those two together and divide by 2. So you get 8. Now that last set of data, it was not in ascending or descending order, so you do have to rework it so that it is. So list the 3 5s, then list the 3 15s. It can be ascending or descending. I tend to use ascending. There were 6 numbers. The 2 in the middle are 5 and 15. So you have to add 5 and 15 and divide by 2. 5 plus 15 is 20. Divided by 2 is 10. So there you go. So the median for that set of numbers is 10. And notice that sometimes averages come out the same. Like earlier, the mean for this first set of data was 7, and now we found the median to also be 7. It doesn't always work that way, but sometimes it does. For this set of data, the mean was 8, median's 8. For this set of data, both mean and median are 10. Not always going to happen that way, but sometimes it does. Okay, now the mode. The mode is the piece of data that occurs with the highest frequency. If there are 2 modes, then the data is said to be bimodal. So yeah, if you have 2 numbers tied for highest frequency, then you've got more than one mode. You can have trimodal with 3 modes or more. Just whatever numbers have, like look at what the highest frequency is, the highest frequency. And whatever numbers have that highest frequency, there's your mode or modes. It's not the highest frequency and second highest frequency. It is the highest frequency. And it is possible to have no mode. All right, so first set of data we had was 4, 6, 7, 7, 7, 9, and 9. 4 appears once, 6 appears once, 7 appears 3 times, 9 appears twice. 3 is your highest frequency. So these 7s here, that's your mode, 7. 9's not included in that because 9 has a frequency of 2. 2 is not the highest frequency here. Okay, next set of data, we had 1, 3, 5, 7, 9. I should have just pre-written this and it would save me some time. 11, 13, 15. Every single number in this set of data only appears one time. The frequency of each of these pieces of data is 1. So this set of data has no mode. There's no number that stands out with the highest frequency. If your entire set of data has an equal frequencies, then there's no mode. And then your 5, 15, 5, 15, 5, 15, that set of data, you have 2 modes. This one's bimodal. Your modes are 5 and 15 because 5 and 15 are tying there with frequency of 3. So notice the difference there. If the highest frequency is 1 for all the numbers, we say no mode. But if your pieces of data all tie for a frequency higher than 1, then you can say, hey, bimodal, trimodal, whatever. All right. And then the last average we're going to talk about is something called the mid-range. That's the number found halfway between the lowest and highest pieces of data. You take the lowest and highest pieces of data, add them up, divide by 2. Okay, so we have our first set of data. We had 4, 6, 7, 7, 7, 9, 9. The lowest one is 4, highest one is 9. So to find the mid-range, add 4 and 9, divide by 2. So you got 13 divided by 2, which is 6.5. And 6.5 is not one of the data points, but that's okay. That 6.5 is halfway between lowest and highest. All right, next set of data. Oh my gosh. Okay, so lowest is 1, highest is 15. So to find the mid-range, you add 1 and 15 and divide by 2. So you got 16 divided by 2, which is 8. And then that last set of data, you're going to be adding 5 and 15 together, dividing by 2. So there you go. So that's how you find the mid-range. So if it's left open to you as to what average should be used, think about how the average is found and think about what it's usually used for. If you're trying to find the mean, you're using that when every piece of data needs to be considered equally. And that's why it's often used when computing grade averages. Because grade averages often are adding up, assessments like tests and quizzes and final exams. And you really want, and if a teacher wants to consider every assessment equally, they just add them up and divide by how many assessments there are. Now in our math classes here at Polk State, we don't want to consider quizzes equal with tests because a quiz is small and quicker and not as hard. Sometimes it's open book, whatever, it's easier. So we don't want to have one quiz weigh the same as one unit test. So what we do to balance it out is we say, well, your quiz average, your mean of your quizzes, counts as a test. And then we add that little caveat in of often dropping a test or replacing a test grade. And then, like in this class, after with your 6-unit test and your quiz average, I drop the lowest, which leaves you with 6 grades, and then your final exam counts like 2 tests. But at that point, those 6 tests plus your final exam twice, I find the mean of that. So I add them up, divide by 8. So it's got some tweaking because we want to make sure that what we're counting equally is fair. The final exam being the big thing it is, we basically end up having it count like 2 tests. So each of those scores that we're adding up and dividing by 8 count equally. Now if data has extreme values, use the median. Some folks who bomb a test wish we'd use the median, others don't. The median, like if you're listening to the news and they talk about average family income or something somewhere, they're probably using median. Because if they were using mean, then families that have millions of dollars would severely skew the average they were trying to quote. So median's used when you don't really want extreme highs and lows to affect the average, the measure of central tendency. Median's good for that. Because mean is very sensitive to extreme data values. So the median helps compensate for extreme data values. If you need to satisfy a certain group the most often, go with the mode. I grumble about this because stores are trying to satisfy women who are sizes 8 and 10 more often than they're trying to satisfy me. Apparently there's not a lot of women my size. I'm not obese or anything, but I'm 5'9". I wear a men's 11 shoe. I'm kind of a big gal. So it's frustrating for me to go shopping because most stores don't want to cater to me. I go to buy shoes and I get very slim selection. And I often end up just buying men's shoes because I can find my size there. And it's not going to pinch my toes or anything. Home sizes might be another one. Like if they're building a neighborhood, they'll probably make sure to put homes in there with the most frequently occurring family sizes in mind, so they know how many bedrooms they want to build. Usually they don't build neighborhoods with homes that have 6 or 8 bedrooms, and usually they don't build neighborhoods with homes that have 1 bedroom, unless we're looking at very specific audience, like maybe a retirement village might build places with 1 bedroom. That's a whole different story though. So, but then in that case, they are still looking at the mode, because they're looking at, well, what's the most often occurring size family unit in a retirement home. It's usually a couple or a single person. And then if the data fluctuates on a regular basis, use the mid-range. Average daily temperature might do this, because like in the desert, it might be super cold at night, super hot during the day. But if they don't talk about average daily temperature, they might go ahead and use the mid-range and take lowest plus highest divided by 2. So if you're trying to compute average, make sure you're aware of which one's the best for your situation. Or if you hear people quoting averages at you, stop and think for a second about what average they're probably using. Don't assume it's the mean every time, because it might not be. That mean might not be the best. So just food for thought. All right, well, thank you for joining me, and next time we tune in, we'll be wrapping up our statistics chapter. Look forward to seeing you.